Alright, we're going to tag on to Mr. Mac's notes, partly because it's giving me a chance to show you the calculator and the end all. And that has a little bit to do with what they call over here numerical instability. That thing over here. And in this case it works because we have an extreme triangle. So what I mean with that is we're going to look at a triangle that has a side length of, that's 1,000,000, that's almost 1,000,000, and then that's tiny. So an extreme triangle is when we have two sides that are almost like this. And then the base is like right there. Okay, right here I have calculated what the semi-perimeter is, but I wanted to take a look at that to make sure that we're okay with that. So the semi-perimeter would be found by taking the sides, right? So we're going to do 1, 2, 3, 4, 5, 6, so it's 1,000,000 plus, and then it's 1, 2, 3, 4, 5, 6 of those, and then 1, 2, 3, 4, 5, and then a 7 and a 9. And then we're going to add to that point, and it's 1, 2, 3, 4, 5 of those, and then 2, 9. We're going to add all those together. I'm going to divide that by 2, and so I get S is 1,000,000. Okay? So that's where S came from. So that's using the calculator. And when I then plug that in to the formula for the area, I was trying to avoid writing that way. So the area is the square root of S times S minus A, S minus B, and S minus C. And then when you fill that in, you get, so we just calculated that the first one here is 1,000,000. So 6 of those, and then we're going to do 1,000,000. Minus, and A is 1,000,000. And at this point, I can basically stop because that's going to give me 0. So this whole square root is going to give you 0 as an area. And that definitely isn't the case. Okay, this area, this triangle has an area. You can find that area by using an alternative way of writing Heron's formula. So this formula could be rewritten this way. So I could have done 1/4 times, and then take the square root of, so we're just adding the square roots. And the parentheses here are important. So it says A plus B plus C in parentheses. So you need to tell the calculator in what order to do things. So I'm going to write this out, and then I'm going to see if you can figure out what the answer is at some point. So it should be 1,000,000 plus, and then we're going to do B, which is 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, and then that, and plus C. And C is 1, 2, 3, 4, 5. Well, I said I was going to write it out. I just want you to see the first one, and then I need to close that bracket, and then I'm going to do this again. And then the next one says C minus A minus B, and then you keep going with that formula. And that will give you a new area. And I'll let you do that on your own, see what you can get. All right. Before you do that, I am going to move on to, we're going to relook at the example that Mr. Mac did earlier. And he used this big formula with, let's see, he used this one over here. Okay, there's a whole bunch of squares and all of the signs, and to me that one is a little confusing. So I tend to not use that one. I tend to use basically this one only. And he did show you where it came from. So, but I like this one. So if I want to use this formula, I need to have both A and B. Well, I don't have B over here. So the other formula came literally just from solving for B. And solving for B can be done with the A over the sine A is B over sine B. Okay, so I could do A over the sine of 115 is B over the sine of not 125, but just 25. So that means that B is 12 times the sine of 25 times the sine of 115. And then you just grab a calculator and I think I have that one set up on another one. I cheated a little bit. This calculator gave me the million that I needed. Technology has gotten a lot better, so that numerical instability has definitely become less and less of an issue. So for example, if I'd used this one over here, this particular calculator would have let me find that the semi-perimeter actually was a decimal number. That's slightly different from a million. Okay, anyway, so here's 12 times the sine of 125 divided by the sine of 115. So that's 10.8460. So in this case, since I'm sort of in the middle of my calculations here, I'm actually going to carry B as 10.486, and then the next one's a 0. So that when I fill in the half times 12 times 10.486 on a calculator, if I didn't have a good graphing calculator, and then times the sine of 40, I would get a good amount of accuracy. Okay, so please don't round this to 10.5. That's way too much rounding to be working with this. Depending on the type of problem, you can run into some serious issues there. So we'll see what that comes out as. So well, that was the answer, right? So that was okay. So and the whole formula said that I needed to do a half times 12 times this number times the sine of 40. So I'm just going to continue from this. I'm going to say times, and the half is 0.5, times the 12, and then times the sine of 40. So I'm not even really using the rounded figure. I'm using exactly what the calculator told me. So in this case, I get 41.83 for my final answer. So 41.83. And I believe that was the same answer that Mr. Mac gave us. See, they did not give me units, did they? So it is units squared. Okay? And that's it for all of the notes for this section. Thank you.